Hey everybody, welcome to Problem Sette number 8, brought to you exclusively by ESPN 8, the Ocho.
ESPN 8, the Ocho.
Wait, hold on a second, Pep. I'm being told that Kyle is blissfully unaware of the age demographic of his viewers, and that he doesn't realize that the joke of this intro will probably be completely lost on them. It's a bold strategy, Cotton. Let's see if it pays off for him. Free worksheet in the description. Let's get started. Okay, question 1. So the first one, guys, this is a probability question, and we need to construct our own two-way table. So just to save myself some writing and make the presentation easier, I typed up the two-way table. So I'm going to pull that up using the magic of television. If you don't want me to ruin this for you, please pause the video and try coming up with the two-way table yourself. That's, in my opinion, the hardest part. Great, we'll be back in a second. Okay, everyone, so I'll just talk a little bit about how I came up with this. So do you see where it talks about the apple trees here and then here? So there's 8 rows of apple trees and they each have 15. So in total, we have 8 times 15, 120. So 8 times 15, that's how we got this. And then 8 rows times 6 unhealthy in each. So 8 times 6 is 48. That's how we came up with that part. And then the bottom row, we follow the same logic. 4 rows of orange trees. And then each row of orange trees has 10 trees that are healthy and 2 trees that are unhealthy. Okay, so 4 times 10, so that's 40 healthy trees. And 4 times 2 is 8. That's 8 unhealthy trees. Then you get these numbers on the side just by adding them up. And then you get the total, which I put in bold, just by adding up one set of the totals. So you don't need to do both, just like, for example, 168 plus 48, and you get 216. You can also just add up the body of the table. So you could do 120 plus 48 plus 40 plus 8. Again, neither here nor there. Let's tackle actually answering the question now that we have the table. So it says, given that the tree is unhealthy, okay, so probability is desired over total, but when the SAT gives us a target group, we have to look just at that target group. So I'm going to look at just the unhealthy trees, which is this column. And it says the probability of selecting an apple tree. So we're going to do desired over total. So apple over total. So apple over total. So that means they said that value was W. So W is the desired over the total in that target group, which is 48 over 56. You can simplify that, but let's not worry about that right now. Okay. Now we'll look at what the second part's talking about. So the probability of selecting an unhealthy tree given that the tree is an orange tree. Okay, so now given, that word given tells me the target group. So I should be looking at just the orange trees. So I'm going to put another box around just the orange trees. Let me do that. And we want to find, again, desired over total. So they want us to find the unhealthy over the total. So that's going to look something like this. 8 over 48. So that means, what did they call that? Z equals desired over total in that target group, which is 8 over 48. Now it wants us to find the positive difference between those two numbers. So the bigger one is W, so we will do W minus Z. So that's 48 over 56 minus 8 over 48. And let's see here, why don't we just show that on Desmos just because that's really helpful. 48 over 56, tab minus 8 over 48. Messy decimal, so I'm going to see if the fraction will fit in the Blue Book app. And that is 5 characters or less for a positive number, so that will fit in the Blue Book app. So the answer to question 1 is 29 over 42. Okay, question 2. So before we start this one, there's a lot of concepts that I've already covered in my other original videos. You're definitely going to want to check out my Ottocento on factoring and my Ottocento on basic quadratics. There's going to be some really important concepts that I'm just going to assume you kind of already know if you've watched this. So we have this big equation with a bunch of like stuff multiplied together equal to 0. So what I'm going to do is I'm going to use what's called the zero product property, which I cover in my Ottocento factoring video. So we're going to set each of these factors equal to 0, because if one of them is equal to 0, then the whole thing must be equal to 0, because 0 times any number is 0. Okay, and okay, so for the left one, it's just a linear factor, so we just get x by itself. So I'm going to add 7p to both sides. 3x equals 7p. Now we're going to divide both sides by 3, and we get x equals either 7/3 p, or you could just say 7p over 3, whatever you want. That's one of our solutions. Now, this one in the middle, you can't factor this unless you know what p is. See, like if we go to factor this using AC method, we kind of need to know what this number is. So, however, what we can do is we could take advantage of one of Vietta's formulas, which I talk about in my basic quadratics video. So this question only cares about the product of the solutions. So even if I don't know what the solutions are, I can figure out their product, because this is a quadratic factor. See, this is x squared, x constant, it's a quadratic. So if ax squared plus bx plus c equals 0, Vietta's first formula tells us that the second formula tells us that the product is equal to c over a. And you guys kind of see, oh, a is 5, b is 8, and c is negative 4p. Okay, so the product is equal to c is negative 4p over a, which is 5. All right, we'll come back to that. Now we're going to do the one on the right. I go over this in my factoring video as well. We've got 4 terms, no common factor, no greatest common factor. So we're going to use what's called factoring by grouping. So I'm going to group these two together, group these two together, and I'm going to pull out the common factor of the blue guys is x squared. So I get x squared times x plus 3. And then this one, it's like, is it 16 or negative 16? Comes with practice, but I'm going to pull out a negative 16. You'll see why in a minute. So negative 16. And then what's left is if I divide both those by negative 16, I get x, and then negative 48 divided by negative 16 is positive 4, so plus 4. And you guys kind of see, oh, I pulled out the negative so that these guys would be the same. If I didn't pull out the negative, they wouldn't be the same, and I wouldn't be able to continue. All right, so as I cover in the video, the two factors, you kind of Frankenstein them together. So one of them is x squared minus 16, and the other one is our, sorry, I messed up here. This 4 should be a 3. 48 divided by 16 is 3. I must have thought it was 12. All right, so these guys are the same. And the other factor is our repeat. So x squared minus 16, x plus 3. We can now factor x squared minus 16 by doing difference of two squares. So that is x plus 4, x minus 4, also covered in my factoring video. All right, so now I've got 3 solutions in this one. You set them all equal to 0, just like we've been doing. It's only one step, so I'm just going to do these ones in my head. X equals negative 4. That's the first one. Second one, x equals 4. 4 minus 4 is 0, right? And the third one is x equals negative 3. Okay, so we pretty much have everything we need. Now it says the product of the solutions is negative 560 over 9. So what we're going to do is we're going to multiply all these guys together, all these solutions or products, and then see what it gives us. And we're going to set it equal to negative 560 over 9. So let's change the color, make that kind of clear. So first thing is 7p over 3, negative 4p over 5. And then we've got negative 4 times negative 3. And this whole thing is equal to negative 560 over 9. That's what the question said. All right. Now I'm just going to kind of, p times p is p squared. And let's see what all these other guys are. I'll just do this on a calculator. 7/3 times negative 4/5, all that stuff together. 7/3 times negative 4/5 times negative 4 times 4 times negative 3. All right, I'm getting negative 448 over 5, so that's the coefficient. Negative 448 over 5. Now I'm going to try to isolate for p. I'm going to divide both sides by negative 448 over 5. I'm just doing that on a physical calculator. I'm getting p squared equals 25 over 36 when I divide both sides by negative 448 over 5. You could use the decimal if you want for that fraction as well. That's probably easier. All right, so now I'm going to take the square root of both sides to get rid of that square. And I get 5/6. And it's really, guys, plus or minus 5/6. It's really plus or minus 5/6. However, if you read the question, it says up here, p is a positive constant. So don't let that fool you. Negative 5/6 totally could have been the answer for another question like this. But we're going to ignore it here just because the question says to make p positive. So I'm thinking the answer is 5/6. I don't know if Desmos would have been that good. You could have done bits and pieces of this on Desmos for sure, but I don't know if Desmos would have been that helpful to get the actual answer. However, I think it's really good for this one to verify your answer. So that's what I'm going to do now. Okay, guys, so as you can see, I just kind of broke the equation up into a system that helps you like click on things more easily, and the colors kind of help you visualize what's going on. This is like an x to the 6th power, so it's crazy zoomed in, so just don't worry about that. All you care about is the x-intercepts, right? So, and I'm doing this on regular Desmos, so it might be a little different than DSAT Desmos, but not in any meaningful way. Okay, so what I did was I just typed in everything. I typed in our answer, p equals 5/6. And then I went through and I found all the x-intercepts. On DSAT Desmos, I think it just goes to the thousands place, so just pretend those numbers are to the third decimal place, just so I don't have to retype it. And you see if I multiply them all together, I get negative 62.1876, and that's very close to negative 62.222. The only reason it's off is because Desmos, like I said, DSAT Desmos rounds to 3 decimal places, so it's just a little bit of round off error, so that's a really good sign that we did it right. So if I had 30 seconds to do this one, if I was going faster at the beginning, I had some time at the end, I would definitely type this in to make sure I did it right. And notice as well, guys, how when I type in negative 5/6, it doesn't really change anything. Well, I suppose I'd have to retype the x-intercepts, but why don't you go see if you could do that. If you relocate the x-intercepts, I bet you'll see that it gives you the same thing, negative 560 over 9. Okay, question 3. So for this one, guys, this is a triangle congruence proof. I think like somewhere around like the 3rd problem set day, we did a triangle similarity proof. So now we're going to do a triangle congruence proof. I already wrote these all down just as a recap. So the rules for similarity are angle, angle, side, 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 SAS. And then for congruence, the ones you got to know are SSS, SAS, ASA, and AAS. If you don't know what these are, I definitely recommend you type this into Google or YouTube, watch a video about it. It helps if you have the pictures in front of you. There's another rule for congruence called hypotenuse leg, but I've never really seen that be helpful in the SAT, so I don't really tell people to worry about that. So I would just make sure for congruence proofs you know these four. So this is what we're going to be using to do the question. Let me get started on the drawing and then we'll talk about it. Okay guys, so I got started on the drawing here. Notice how I was very careful to I don't know, when I do these I like to start at the top, A, B, C, J, K, L in the exact same order they gave me. The letters in the congruency statement, that's really important. And I put all of the given information from the question just in purple. And then when we go through the answer choices, I'll use a different color. So the 44 degrees and the 25. So hopefully you're kind of noticing, okay, this would be like AS, and that's not one of the rules for triangle congruence. You need at least 3 pieces of information, 3 pairs of pieces of information. So it's not no additional information necessary. They're not already congruent. So why don't we start with answer choice A and we'll kind of work our way down. So the length of side AC is 13 and the length of side JL is 13. Okay, so this is giving me if I look like this, it's giving me SSA, and that was not one of the rules we came up with for congruence. So that is not right. So let me erase this. A is wrong. Okay, let's try this next one. So angle A is 58 and angle L is 58. Okay guys, this is kind of tough to see, but do you see how one of them is giving me AAS and then the other one is giving me ASA? These are not the same, right? And if I label the third angle, let me do some math real quick. 180 minus 58 minus 44. I get 78. And hopefully you guys are noticing, wait, the angles that correspond aren't the same. All the angles are the same, but the angles that correspond aren't the same. So that congruency statement is not true. And as a matter of fact, I think this one isn't congruent. We can almost definitively say it's not congruent. We can say it's similar, but it doesn't give us one of our 4 rules. So this one is out. Let's look at answer choice C. So the measure of angle A is 37, and the measure of angle J is 37. Okay, that looks a lot better. See how they're in the same spot? That already bodes well, right? It's like, okay, I got another piece of information for both of them that are the same. So now the question is, does it give me one of the rules? And I'm looking, and if you know what all those rules at the bottom are, angle, angle, side. Angle, angle, side. Oh, so they're perfectly in the same spot, and we get the rule angle, angle, side, which tells us that they are congruent. That's one of our 4 main triangle congruence rules. So C is the answer to this one. Okay, question 4. So this is very similar to a Blue Book app question that was just added. I just made it a little bit harder, primarily by removing the answer choices. So there's no answer choices, so it's going to be really hard to guess and check or use Desmos solely to answer the question. So here's the concept they want you to understand. This is called factor theorem. You can give that a Google, go to Google Images if you want. Factor theorem. So if k is a root, then x minus k is a factor. Now, it's not really helpful for this one because the factor's in kind of this wacky form, like 4k minus x, right? So it's better if you just kind of understand it conceptually. So if something's a factor, whatever makes the factor equal to 0 is going to make the expression equal to 0 as well. So let's try to figure out what makes the factor equal to 0. So this factor, 4k minus x, I'm going to add x to both sides, and I get 4k equals x. That's it. So when x equals 4k, that whole expression is going to be 0. If you want to think about it making a graph, this guy should be an x-intercept. So 4k comma 0. X-intercepts always have a y of 0. Okay, so if 4k makes the factor 0, it should also make this big messy expression, which I will call q of x just for question, doesn't matter. It'll also make that equal to 0. So I'm going to plug this point in. So 0 equals 4k cubed minus 72 nk cubed. And let's see, 0 equals 4 cubed is 64. K to the power of 3 is just k to the power of 3. Now to solve this, we are going to factor using a greatest common factor. That's the first thing you should do whenever you see a factoring question. The greatest common factor of numerical factor of 64 and 72, it's 8. But if you didn't know it was 8, you could use this little expression GCD, greatest common divisor, to help you figure that out. Anyway, so we're going to pull out an 8. And we're also going to pull out something else that they have. See how they both have a k to the power of 3. So we're going to pull out a k to the power of 3. And if you're having trouble seeing what's left in your head, just like divide. Remember, pulling out a GCF is like pretty analogous to division. And I'm left with, let's see, 64 divided by 8 is 8. And then minus 72 over 8 is 9. The k cubes go away, but I still have an n. So I've got kind of 3 core factor bases that I'm going to use the zero product property on. Well, 8 is just 8. So there's no way that can be 0, right? So we've got k. Doesn't matter that it's cubed. 0 cubed is still 0, right? So k, and we've got 8 minus 9n. So either k equals 0 or 8 minus 9n equals 0. So for this one, if I add 9n to both sides, I get 8 equals 9n. And then I divide both sides by 9, and I get n is equal to 8 over 9. Now, which is it? Well, if we go back to the beginning of the question, and we see it says, oh, k is greater than 0. Okay, well, 0 is not greater than 0, so it can't be this one. So it's got to be 8 over 9. N is equal to 8 over 9. That is the answer for this one. Now, again, I don't know how helpful Desmos would be in the heat of the moment, but when you're done, if you understood this at least a little bit, you could absolutely check it on Desmos. So let's do that now. Okay, guys, so I just typed in the x-intercept we came up with, which was 4k comma 0, because that makes the factor 0. I typed in some arbitrary positive value for k, and I typed in our answer, and I typed in the expression. And you see, no matter what k is, as long as n is 8 over 9, it's going to go through that root. I just made k equals 0.5 because I want you guys to see, oh, it's a cubic, and they were basically just telling us one of the factors of the cubic, and it's really nice. You can see the cubic goes through that x-intercept, or root, as we like to call it sometimes. Okay, question 5. So a lot of the concepts I've already covered in my other original videos. Definitely check out my Ottocento on percents. If you're pressed for time, I believe I have 5 shorts on the, you need to watch all of them to get this problem, but 5 shorts, and the one that's most relevant to this is called percent relations. It's not perfect, but it's probably a good primer for this problem. So definitely go check out all those videos. All right, before we start doing the words to math, Let's just do the kind of multiplier math in that second sentence just on Desmos, just so that no one gets confused by that. Okay, so to calculate a percent multiplier, we do 1 plus percent over 100. So for percent increase, 1156% more, so it's an increase. More means increase. 1156 over 100. Okay, so for the rest of the problem, that part means 12.56. And then the second part says 62.5% of. So when we do a percent of, to get the multiplier, we just divide by 100. So 62.5 divided by 100. I would just autopilot do this on Desmos every time because you're going to make a mistake if you don't, especially when there's answer choices. It almost makes it harder because the answer choices trick you. Okay, so write those two numbers down. Let's go back to the whiteboard. Okay, so it says A is, that means equals 1156% more. Well, as we just talked about, that was a multiplier of 12.56. And then it says the positive difference between B and C. Well, so it's that entire quantity, so I need to put parentheses around it. And the question is, in the parentheses, do I put B minus C or do I put C minus B? Well, you'll notice the question at the beginning, they tell you B is bigger. So we should put, for a positive difference, we should put the bigger one first. Think about it. 10 minus 2, that's 8. But 2 minus 10, that's negative 8. So pretend the B is the 10. So we're going to put the B first, B minus C. Okay. And the second equation, we're going to do the very same thing. C is means equals 62.5% of, we just talked about that's 0.625. And then times just B. Okay, so now we need to make a little bit of a plan of attack. You're going to see if you read all this stuff down here, both of these statements are relating A and C. So the crux of the problem is we need to come up with an equation that relates A and C. So this is difficult to kind of strategize, but I don't want to isolate anything in here. This is going to be a big mess. So what I'm going to do is I'm going to get B by itself here and then substitute it in here. It'll make sense in a minute. And we'll just get an equation in terms of C. So I'm going to divide both sides by 0.625. And I get, I'm going to also switch it around. Hopefully that's okay. B equals, this guy goes away. And 1 over 0.625, you could do a fraction, but this one actually comes out nicely, is 1.6. So this is B equals 1.6C. Going to put a box around that. Now, hopefully you guys kind of see where I'm going with this. I'm going to put this in for B, and then I will have an equation that relates A and C. So we're in business now. So let's say I have A equals 12.56. Remember, B is 1.6C minus C. Well, 1.6C minus C is just 0.6C because 1.6 minus 1 is 0.6. And then I get A equals, what's 12.56 times 0.6? 7.536. C. And that's going to be one of our equations. And you'll notice, oh, it's one of them has A is by itself. So we want an A equals equation. But we also want a C equals equation. C is. So we're going to get a C equals equation as well. I'll just do that off to the right. And if we divide both sides by 7.536, comes out all messy. I should probably just round at the end. I'm doing this on a calculator, guys. I'm getting C equals 1 over 7.536 on a calculator. you could use Desmos, is 125 over 942A. So if I now hold the sentences up to these, you guys will kind of see, wait a minute, A is P% greater than C. That goes with that one. And then the other one, C is W% of A. C is W% of A. All right, so now there's a little bit more arithmetic we got to do, then we're done. We're basically done. So P% greater, that's a percent change. So I go over this in my percents videos. 100 times the percent multiplier minus 1. So I'm going to take away 1. Then I'm going to multiply by 100. So P is equal to 653.6. And then W, to go from percent ofs from their multiplier, all we're going to do is multiply by 100, just kind of like the opposite of what we did before. Divide by 100, multiply by 100. Very confusing. So you see the key words in the question tell you whether you need to take away 1 or not. So that is really important. All right, so I don't know. I'm just going to, we don't need to be super accurate. So why don't I just do 13.2696. And then the question wants us to find PW to the nearest integer. So PW is I'm getting like 8673.01 to the nearest integer. That'll be 8673. And I believe that is the answer. Now, I did make a Desmos graph, but there's no graph, right? It's all just this, what I just wrote. And it would be kind of hard to fit on the screen. So if anyone wants to see my like little Desmos solution of this, maybe it'll help you follow along better. Just comment in the video and I'll put it in the reply. Just, again, hopefully like just 1 or 2 people do it. Just check the comments, see if I already responded to someone else. Okay, question 6. So, I mean, definitely watch the factoring video, the auto-change on factoring, but I cover this exact question type, just maybe a little bit easier. This is from the Blue Book app, but I covered it in my advanced quadratics video. So definitely go check that out. If you watch the advanced quadratics video first, this will make a lot more sense. Okay, so ax squared plus bx plus c. Again, guys, I know they are using the same letters as in the textbook. They're not the same. A is not the same A in the problem. So I'm going to use colors. So A is the yellow. B is the green. And C is the constant term, anything that doesn't have an X. Great. So let's write this all down. Capital A. I'm putting air quotes around it just to remind you guys that it's different. 10b plus 6a. B is equal to 9a squared minus 25b squared. And C, air quotes, is equal to negative 12ab. Question is talking about the sum of the solutions. So we're going to use Vietta's first formula, negative b over a. And you see the expression for the sum we're going to get from the question, which is right here. So purple is going to go here. Green is going to go here. And A is yellow. Yellow is going to go here. Just don't forget about that minus sign that's already there. All right. So K, 21A minus 35B equals minus the green, which is 9A squared minus 25B squared. over A, which is the yellow, 10B plus 6A. Great, that was probably the hardest part. Hopefully you're kind of just thinking at this point, wait, we see these like rational expressions. Oftentimes when we see rational expressions on the SAT, crucial to the question is factoring. So I'm going to go and factor all three of the pieces. So K, we got a greatest common factor of 7. So I'm going to pull out a 7, and I'm left with 3A minus 5B. And then on the bottom, I'm going to rearrange it as 6A plus 10B because that's the same. You're going to see why I'm doing that in a minute. Actually, no, I won't do that. We're going to pull out a greatest common factor of 2. I think that's all they have, right? So 5B plus 3A. And then the minus sign. And then for this one, we're going to factor this guy up here using difference of two squares, which I cover in my factoring video. A squared minus B squared. That might not be that helpful with all the letters in this question. How about U squared minus V squared equals U plus V, U minus V. How about that? Just to give you something to look at while we're talking about that. So I take the square root of both of them. 9A squared square root is 3A. Notice this minus sign. Square root of 25B squared is 5B. So it's 3A plus 5B. And then 3A minus 5B. So the first thing I notice is that 5B plus 3A and 3A plus 5B, those are the same thing. Addition is commutative. So I can cross this out. And I get 7K 3A minus 5B equals negative 3A minus 5B over 2. And the other thing I notice is that there's a 3A minus 5B on both sides. So I can divide both sides by 3A minus 5B, and these guys will go away. Just remember, when you clear a numerator, you have to put a 1. So 7K equals negative 1/2. And now I'm going to divide both sides by 7. And I get K equals negative 1 over 14. Once again, guys, Desmos might not be super helpful because it might be hard with the rounding to get the exact answer. However, it is really good for verifying our answer, as I cover in my advanced quadratics video. Let's go do that now. Okay, so as you guys can see, I pretty much just typed in the equation and our answer, the expression for the sum of the solutions from the question, and then I got the sum of the solutions from the graph. We'll talk about that in a second, but first, just make sure you guys understand, they said A and B were positive constants, so I just picked random numbers for A and B. Never pick 1. 1 has a lot of special properties. Pick like 2, 3, 4, 5, 6, 7, and really any of those, 2, 3, 4, 5, 6, 7. So I made A equals 2, B equals 3, and we got 2 solutions, looks good. And the solutions, the DSAT version should round to the thousands. So that's why I rounded to the thousands to try to replicate that. So the sum atom, so negative 0.353 plus 4.853, and I get 4.5. And then the expression for the sum I typed in, then I typed in our answer, and you see they're the same. Both give me 4.5. And even if it was a little off, that probably means you still did it right. Just remember there might be some round off error from Desmos rounding to 3 decimal places. Okay, question 7. So this is what I call in my videos slope proportions. I've got Ottocento number 8, which goes over this in tremendous detail. Please go watch it. And there's also a short on slope proportions. If you're pressed for time, go to the shorts tab. One of my earlier ones is slope proportions. Anyway, so first things first, this equation is not given. We're going to need the slope, okay? And you see, we can't really figure out the slope by looking at that. We're going to have to distribute that 3/4. And 3/4 times 26/7. Let's see what that is. I'm getting 39/14. So that's 39/14 x. And then if you distribute this guy and then add this guy, you're going to get some like constant term, which is just going to be the y-intercept. I'm not going to do the rest of that. You can do that if you want. It's not relevant to the question. We just need the slope. So the slope is this thing in front of x, 39/14. All right, so m is equal to delta y over delta x. Let's say you do a slope proportion. First, you identify what x is, then you identify what y is. X is what's inside the parentheses, really important to understand. In this case, they just used x. That's convenient. And y is the name of the function outside the parentheses. So I'm going to rewrite this so that I don't make a mistake as delta t over delta x, because they use t for y and x for x. All right, so now I got to read the question. Kyle invented a new temperature scale. He called the Tudor-Lini scale. The function t gives the temperature in degrees torta that correspond to the temperature of x degrees Celsius. Okay, man, dude, informative and funny. You guys should subscribe to this guy. All right, so this part here, this part here sounds like a change, right? So the question is that a delta x or a delta t? Well, it's a delta t because it says degrees torta, right? And because it says increased, it's a positive change. So we're going to put a positive 3.3. See how we're putting that next to delta t? That's why I wrote it like that, to make it as clear as possible so I don't make a mistake. And then the delta x is what we're trying to find. So why don't I just leave that as delta x? And we're going to set that whole thing. Remember, guys, at the beginning, that whole thing is equal to the slope. So the slope we said was 39/14. Now we've got this guy, and we are super in business. So what we're going to do is we're going to cross multiply and divide. Cross multiply. So 3.3 times 14. So we get 39 times delta x equals 3.3 times 14. That's 46.2. I divide both sides by 39. Calculator's telling me that I get, when I type in 46.2 over 39, simplifies to 77/65. And that is the corresponding temperature change in degrees Celsius. And that would be our answer. It would actually work because look, 1, 2, 3, 7, 7/65. That's 5 characters that would fit in the Blue Book app. I'll show you guys some stuff on Desmos. Give me 1 second. Okay, so this is probably what I would have done on Desmos. And you see I just typed the equation in. Then I typed in y equals 0, y equals 3.3. I just picked some arbitrary starting point. So how about 0? And then it said the torta, which was y, as we talked about, went up by 3.3. So I just drew both those. And then to calculate what the x went up by, I just did subtraction. But you'll notice, guys, remember, the actual Blue Book app should round that to 3 decimal places, so it's not as accurate. And you'll see that would get you the right answer. 1.184 would have been an acceptable answer. But it's like if it's a student-produced response question, you're not going to get the actual answer. You're not going to get the exact answer. So just kind of take that with a grain of salt. I think it's super worth it. As I talk about in my Ottocento number 8, I think it's super worth it to have a deep understanding of slope and do it by hand, even if you can do it on Desmos, because understanding slope is one of the most important things on the test. It will help you get other types of questions correct. Okay, everyone, that completes the lesson. Thank you so much for watching until the end of my video. I greatly appreciate it. If you are taking the Digital SAT on August 24th, I wish you the best of luck. And I want you to know that I'll be having a post-DSAT live stream on Saturday after the exam from around noon to 3 p.m. Eastern Time. I hope you can make it. And as always, thanks for stopping by.